Hey everybody, welcome back to Soft Spoken Scientist. Today we're doing solubility and precipitation reactions. I'm going to explain this the way it should have been explained the first time. What's happening in water, why we write ions, and why we swap partners. We're going to go step by step like a classroom. We will finish each step, each problem, all the way to the end. So, what does aqueous really mean? When something is labeled AQ, as you guys see right here, that means it is dissolved in water. In Gen Chem 1, when an ionic compound is dissolved, it separates into ions. So aqueous solutions are basically a mixture of ions moving around. So here you got AQ equals dissolved in water, so the ions separate. S is a solid, the ions are not freely moving. L is a liquid, G is a gas, okay? Precipitation reactions happen because certain ion combinations are not stable in water. When two ions form a compound, that is insoluble. They leave the solution and form a solid. So, part 2, what a precipitate is and why a reaction happens. A precipitate is an insoluble solid that forms when two aqueous solutions are mixed. The reason we care is simple. In aqueous chemistry, a reaction is considered to happen when something is removed from solution, like a solid forming. So we have a precipitate, which is, again, insoluble solid that forms in solution. If everything stays aqueous, then nothing is really changing. There's no driving force. But if a solid forms, the system is removing ions from solution, and that is a real reaction. Okay? So, here's the solubility rules. We don't memorize every salt. We memorize patterns. So check this out. On the periodic table, group 1, like lithium, sodium, potassium, that's soluble. NH4 plus is soluble. NO3 minus is soluble. Usually soluble are chloride, bromide, iodine, except Ag plus, Pb2 plus, mercury 2 plus. Usually insoluble is CO3 2 minus, PO4 3 minus, OH minus, except group 1, calcium, Sr, and Ba. Write these down. It's fundamental. Before we do practice problems, let's talk about it. Why are we swapping partners? When you mix two ionic solutions, you don't have two intact compounds floating around. You have ions floating around. For example, sodium chloride in water. It's not NaCl molecules. It's Na ions and Cl ions moving around. Same with silver nitrate. It becomes Ag positive and NO3 minus. Once all these ions are mixed together in the same container, ions can bump into each other and potentially form new combination. If one of those new combinations is insoluble, those ions stick together and drop out as a solid. That is why we swap partners. We are checking which ion pairings are possible and whether any of those pairings form an insoluble solid. In a double replacement reaction, which I'll do another video on, the positive ions trade negative ions. The reason is charge attraction. Positive wants negative. If the new positive-negative pair is insoluble, it's going to become a precipitate. So, let's look into problem 1. When aqueous silver nitrate is mixed with aqueous sodium chloride, does a precipitate form? If yes, what is it? So step 1, write the compounds with states. Silver nitrate. Silver, Ag, nitrate, NO3, and then it's aqueous. Is mixed with aqueous sodium chloride. It's aqueous. They are aqueous, so they dissociate. Step 2. See, I even wrote it nicer. Step 2, write the ions. So we know that they're dissociating, so I'm going to break this down into Ag NO3 minus, NO3, which I had. I'm going to break it into Ag and NO3 minus. The charges come out once we broke them apart. Okay, I'm going to do the same thing for Na. Na positive, and then you get chloride negative. And if you notice, they canceled out, and there's no charge here. Canceled out, no charge here. Now in the beaker, we have Ag positive, NO3 minus, Na positive, and Cl minus, all floating together, okay? So, let's look at step 3. We have to test new pairings. This is the swap partners, right? So what we're going to do is we're going to swap partners completely, to form the new combination. So I see Ag, and I know that it's going to go with chloride. It's like diagonal opposites. And then NaNO3. Okay? So this is what we got. Nitrates are always soluble. So NaNO3 stays aqueous. Now, AgCl. Chlorides are usually soluble, but Ag plus is an exception. So AgL is insoluble. And if you're insoluble, you're going to form a solid. So AgCl, I should say, forms a precipitate. That solid forming is the evidence a reaction occurred. Okay? When aqueous sodium chloride is mixed with aqueous potassium nitrate, let's break that down. Sodium chloride, it's aqueous, is mixed. That means you are mixed with something, the plus sign. Potassium nitrate is aqueous. Does a precipitate form. Step 2 is to write out the ions. Na positive, Cl minus, K positive, NO3 minus. Do your opposites. These go together. And then these go together. NO3 minus is always soluble. Group 1 always soluble. KCl is soluble. So we got KCl and NaNO3. Everything stays aqueous, no solid form, so no precipitation reaction occurs. There's no reaction. When aqueous barium chloride is mixed with aqueous sodium sulfate, and let's stop right there. Barium chloride. Because remember, this is and you may be saying, well, how'd you get BaCl2? I'll do another video specifically for that. Ba is raised to the second power. Cl is raised to the first power. Cross multiply. So you got Ba with a 1 that's invisible with Cl2. That's it. So BaCl2, aqueous, is mixed with aqueous sodium sulfate SO4, which is aqueous. So we got step 1. Then we got Ba2 positive, Cl minus, and a positive SO4 2 minus. This is what we got. Ba is going to go with SO4. First one to the last one, these would go together. And NaCl would obviously make sense. So we got Ba SO4 and NaCl. BaSO4 is insoluble. So it's going to precipitate. Done. So here's the clean takeaway. Swap partners because ions mix freely in water. A reaction occurs if an insoluble solid forms. If everything stays aqueous, no reaction. Always check solubility rules up there. And remember, please to hit that like button for me and for yourselves. Please hit that subscribe button for me and yourselves. Let's grow as a community and make STEM fundamental and let it take over the world, right? We want to change the world. And I want you guys to know, STEM is for everybody, especially you. Thanks for tuning in.